Hello everyone, this is Srujana. Now we are going to learn about solar photovoltaic system with its applications. These are the contents. Introduction. A solar photovoltaic system is a technology that converts sunlight into electricity using solar cells, which are typically made of silicon. The term photovoltaic refers to the process of converting light directly into electricity. Solar photovoltaic systems can be used for a wide range of applications, from powering small electronic devices to generating electricity for homes and businesses. The electricity generated by a solar photovoltaic system can either be used immediately or stored in a battery bank for later use. Excess electricity generated during the day can also be fed back into the grid for credit or sold back to the utility company through net metering programs. Solar photovoltaic systems are a clean and renewable energy source that can reduce dependence on fossil fuels and lower carbon emissions. They are also becoming increasingly cost effective, making them an attractive option for homeowners, businesses, and governments alike. Components are solar array, cabling, mounting systems, solar trackers, solar inverters, charge controller, and battery. Classifications are thin film technology, silicon film technology. In thin film technology, silicon deposited in a continuous on a base material such as glass, metal, or polymer. The efficiency ranges from 5% to 13%. Pros: low cost substrate, cons: not very stable. In silicon film technology, currently makes up of 86% of PV market. Very stable with module efficiencies 10% to 26%. Monocrystalline PV cells, polycrystalline PV cells. Working of solar cell. Photovoltaic cells are made up of at least two semiconductor layers, one layer containing a positive charge, the other a negative charge. Sunlight consists of little particles of solar energy called photons. As a PV cell is exposed to the sunlight, many of the photons are reflected, pass right through, or absorbed by the solar cell. When enough photons are absorbed by the negative layer of the photovoltaic cell, electrons are freed from the negative semiconductor material due to the manufacturing process of the positive layer. These freed electrons naturally migrate to the positive layer, creating a voltage differential similar to the household battery. When the two layers are connected to an external load, the electrons flow through the circuit creating electricity. Each individual solar energy cell produces only 1 to 2 watts. To increase power output, cells are combined in a weather type package called a solar module. These modules are then wired up in a serial and or a parallel with one another into what's called a solar array to create the desired voltage and amperage output required by the given project. Construction of solar cell. In p-type semiconductors, holes are the majority carriers and electrons are the minority carriers. P-type semiconductors are created by doping an intrinsic semiconductors with acceptor impurities. A common p-type dopant for silicon is boron. N-type semiconductors have a larger electron concentration than hole concentration. The phrase N-type comes from the negative charge of the electron. In N-type semiconductors, electrons are the majority carriers and the holes are the minority carriers. A common dopant for N-type silicon is phosphorus. Applications of PV. Commercial lighting. PV powered lighting system are reliable and low cost alternative. Security, billboard sign are viable applications for PV. Consumer electronics. Solar powered watches, calculator and cameras are all everyone for PV technologies. Telecommunications, residential power. Concluding remarks. The key to successful solar energy installation is to use quality components that have long lifetime and require minimal maintenance. The future is bright for continued PV technology dissemination. PV technology fills a significant need in supplying electricity, creating local jobs and promoting economic development in rural areas, avoiding the external environment costs associated with traditional electrical generational technologies. Thank you.